Hi kids. Today you're going to see some differential equations inside of word problems. A lot of these will be familiar to you because you've done things like this before. It's all about the setup, and then it's the same thing that we did late last week with separating and integrating. So this worksheet with all of these questions on it is available to you in OneNote, and there's a link to it in Canvas, so you can get to it any way you want to. But we'll do one together, and then I'll put answers to the rest up in Canvas. All right, let's buy a car. Cars depreciate in value. As time goes on, their value goes down. The change in a car's price is directly proportional to its current value. All right, so that is your differential equation written in words. The change in a car's price is directly proportional to current value. So change in price is what we're going to call our derivative. So I'm using P for price, the change in the price, so that has the change in price over time is, there's your equal sign. Now, we didn't talk about this much on Friday, but directly proportional means you need this thing called the constant of proportionality. I almost always use K for that. I've only ever seen AP tests use K for that as well, so we'll use K. Directly proportional to its current value or its current price. I guess you could use those interchangeably, so KP. Okay. Suppose you own a car, congratulations, whose trade-in value is presently $9,000. So we're going to say right now at time zero, its cost or its price is $9,000. 6 months ago, its trade-in value was $9,500. So if I'm doing 6 months ago, I can do this, -6 and then 9,500 to show the change in time, the passage of time. But remember, it's all relative. So if you don't like this, if you don't want to think about -6 months ago, let's call that one our 0. And let's just start time 6 months ago. And then this one, so our present value is the 9,000. Okay, write and solve the differential equation that expresses trade-in value starting 6 months ago. Well, I've written it. Here it is. There's my derivative. There's an equal sign, so it's a differential equation. To solve it, I have to separate and integrate. That's what we did in Friday's video. So I'm going to divide by P, multiply by dt. K is a constant. Don't be afraid of it. It's just some number. We're actually about to go find it. When I integrate both sides, I get natural log absolute value of P equals KT plus C. Okay, now I have a lot of unknowns in this question, or in my equation now. P is going to be there and T is going to be there, but I have to solve for K and C. I have to find both of those. So that's where this information comes in, those 2 points I found. I'm going to plug them in and solve for whatever's left. So when you do that, you're only going to plug in one at a time. I'm going to start with the one that has a 0 because that makes life easier to use zeros first. So if we plug that in, we get the natural log of 9,500 equals 0 plus C. Okay, got it. So C is natural log 9,500. And then I'll do the same thing by plugging in 6 and 9,000. So natural log of 9,000 equals KT plus, now I know what C is, so I can sub that in. And I can rearrange to find, I forgot to put T in. T is 6, sorry. 6K, let me put it that order. Okay, now I can rearrange to solve for K. So K is going to be the natural log of 9,000 minus the natural log of 9,500, all divided by 6. So I've solved for all my things. I've got K, I've got C, so I don't have any more unknowns. This is just bothering me so much I can't stand looking at it anymore. We can use log rules to make it look nicer. So it's the natural log of 9,000 divided by 9,500. And we can clean that up even more because we can divide our fractions. And I know that 9,000 divided by 9,500 is just 18/19. It's still over 6 too. So I'm going to write it as this, 1/6 times the natural log of 18/19. I just think it looks cleaner because that's about to go into my equation. Okay, so if I put all of that together, I am back to this original natural log absolute value of P equals K, which is now 1/6 natural log of 18/19, T plus, and C is natural log of 9,500. If they asked nicely, I could solve this for P. I could get P alone. But they didn't ask. So I probably won't. Because when I read ahead, it's not necessary, but I do want to show you one quick thing. It's actually really pretty when you clean it up. Because if I were going to get P alone, I would have to base E both sides of this equation. So I'd end up with P on the left-hand side. I don't need the absolute value because the price isn't going to go negative. I'm not concerned about owing money. My car is so old that I owe money if somebody takes it from me. When you E both sides of it, remember that you have to do the entire right-hand side as one chunk. Oh my gosh. Remember when I said it was going to be nice? Maybe I lied. I didn't lie. I don't lie about stuff like this. So then you can use your exponent rules. This is the same thing as E, all this. I'm glad I cleaned it up because I have to keep writing it. Times, like that. Because if they have the same base, you add the exponents. So I'm just going the other direction. And then looky here, I've got E to a natural log, which is going to cancel. And I can make this one cancel too if I birdie, actually all of this. So let me rewrite this one. That was too fast. So, So I'm going to rewrite this one. So this is E to the T over 6 times natural log of 18/19. And then this is time 9,500. I'm going to birdie this up, use that birdie rule for my exponent rules so that I can do the same thing where I cancel my E, my natural log. You can't do that when you have a coefficient in front. You have to use all your log rules first. So let's see, E natural log to the T over 6 times, and then these go as well. So your price is actually 18/19 T over 6 times 9,500. And you might be used to seeing it the other way. With the 9,500 in front, it doesn't matter. Okay, so that's as clean as it gets. There are going to be situations where you want to clean it up all the way. It just depends on what kind of follow-up questions they ask. So I'm still in number 1. Let's read the rest of the questions. What will the trade-in value be 6 months from now? Okay, so remembering that now is actually time 6. They're asking what is P when time is 12? Okay, well, I can plug a 12 in there and get P alone and solve it. That's not a problem. And then for letter C, you plan to get rid of the car when the trade-in value drops to $6,000. So when your price is $6,000, what is the time value? And that's what you're going to do there. Now down here, because I took the time to do it, this is a lot faster, especially for the one where I'm plugging in a time value, a time of 12. Plugging in a time of 12. And then cleaning that up, that's not so bad. And even rearranging with your p-value. Okay, I am going to leave the rest for you for homework because Delta Math does not have these questions. So this is where you're going to go to work. But I have answers posted in OneNote, and I'm going to help you set this one up. L of T represents the number of students in a school who buy their lunch after T weeks. Good for them. L is increasing at a rate proportional to 600 minus L. Constant of proportionality is K. Okay, so L is increasing at a rate. So the rate of L is proportional to, that's your constant of proportionality. And then you have 600 minus L. L. All right, that's what you're going to separate and integrate, and then solve and use your follow-up questions. Solve for C and K and use your follow-ups. All right, kids, let me know if you need anything.